This presentation describes a project to build a simple device called a sun gauge. It is used to measure the distance from the Sun to the Earth as well as the Sun's diameter. It is adapted from Sun Measurer, a procedure created by Michael Pollock and Tom Gates of the Resource Area for Teaching, which is often called RAFT. The first step is to purchase a 12-inch by 12-inch square piece of masonite or MDF board, that is 1/8 inch thick. This can be obtained from a local hardware store or such stores as Home Depot or Lowe's. Next, cut the board into 2 square pieces as shown in the diagram. Each piece should measure 5 inches by 5 inches. In metric measurements, the sizes would be 127 mm by 127 mm, and 4 mm thick. Designate one of the plates as A, and the other one as B. For plate A, obtain a drill bit that is 1/16, or 1.6 mm in diameter, and mount it in a power drill. As shown in the diagram, use the drill to make a pinhole in the exact center of the square board. Next, place an adhesive-backed, white paper hole reinforcement ring around the hole on both sides of plate A to identify the location of the pinhole. Paper reinforcement rings are used on hole-punched paper, and can be obtained from a local stationery store. The next step is to draw a rectangle on a piece of white paper that measures 1.75 inches wide by 2.75 inches long. In metrics, this would be 45 mm wide by 70 mm long, as shown in the diagram. Now, using a stencil, draw circles with diameters of 3, 4, 5, 6, and 7 mm, then mark the circles as shown in the diagram. Finally, cut out this rectangular piece of paper. This will be the measuring gauge. Paste or tape the paper gauge prepared in the previous step, to the center of plate B as shown in the diagram. The diagrams and photos show the completed plates A and B for the sun gauge. Now, build a holder for plates A and B to complete the sun gauge. To do this, purchase a piece of wood corner molding from a local hardware store or such stores as Home Depot or Lowe's. The length of the molding should be at least 36 inches long, with the sides at an angle of 90 degrees as shown in the diagram. Using a saw, cut the molding into a piece that is 27.5 inches long, or in metric measurements, 700 mm long. These moldings typically have a thickness of 1/4 of an inch or 6 mm. The sides are typically 1.5 inches or 35 mm long, as shown in the diagram.
To complete the sun gauge plate holder, use a saw with a 2.5 mm thick blade to cut 2 slots in the plate holder. The slots should be located 100 mm from each end, and at a depth of 15 mm, as shown in the diagram. If available, a miter saw is ideal for making these cuts. A photo of a complete plate holder, made from pine corner molding, is also shown in the diagram. Now, slide plates A and B firmly into the slots to complete the assembly, exactly as shown in the photo. Using the sun gauge assembly, position the sun gauge so that the sun's image is centered on one of the holes on plate B, as shown in the diagram. With the sun at your back, place the assembly with plate A over your shoulder. Position the sun's image so that it is centered on one of the holes on plate B. Record the diameter of the hole where the sun's image is projected. The key measurement to record is A, as shown in the diagram. The diameter of the sun's image on plate B is the value A that you recorded in millimeters. Convert the value for A from millimeters to kilometers. This will give you a very small number, less than 1. The value for C, which is the diameter of the sun, is known to be 1,392,684 kilometers. Since you know that the distance B on the plate holder is equal to 500 millimeters, Convert that to kilometers. Now calculate the distance from the Earth to the Sun, d, in kilometers using the equation d is equal to c times b divided by a. Using the measurement you made for a, you can also calculate the diameter of the Sun. First convert the values for a and b from millimeters to kilometers. This will give you very small numbers, less than 1. Now calculate the diameter of the Sun, c, when it is farthest from the Earth, which is 152,100,000 kilometers. That is the value for d. Finally, use the equation where c, the diameter of the Sun, is equal to d times a divided by b. This presentation was produced as a public service to help middle school and high school science teachers develop experiments, presentations, and demonstrations that can be used in their classes. More science experiments and demonstrations are available on the Tops of Santa Clara Valley website, www.topsofscv.org. TOPS, Teaching Opportunities for Partners in Science, is a program aimed at stimulating greater interest in science by middle school students.